session we would be talking about the concept of weathering and erosion. Now what is weathering? When I say there is a rock mass and it kinds of disintegrates or break down into smaller rock mass or smaller rocks, I can say this is the process of weathering. But if this same rock mass, once it is broken down, it gets transported by various agents, I could say in presence of various agents, this would be known as erosion. So in simple terms, if I want to write down an equation, I can say erosion is a result of the process of weathering as well as transportation of the weathered rock material would be known as erosion. So that is the basic and the most fundamental difference between what is erosion and what is weathering. Now when I say weathering, what are the basic characteristics of weathering? How can we differentiate weathering and erosion, and what are the basic functions that that the process of weathering will do? So when I say the characteristics and functions of weathering, I can say first of all, weathering is a kind of in situ process, while in erosion there is removal of soil. The next is, so it's breaking down of the rock particle, that means there is decrease in the strength of the rock, but at the same time it is increasing the permeability. That's one of the fundamental things. The strength of the rock definitely weakens down, but the permeability or as well as porosity, we have already talked about the concept of permeability and porosity in the previous class where we had talked about soil erosion. So permeability and porosity increases in case of weathering of the rock. Then again, weathering is important as it helps in formation of various landforms. Now, when we go further, we'll be talking about two different kinds of weathering processes, the three basic different kind of weathering processes. One is biological, one is physical, and another is chemical weathering. So when we understand those, we'll understand this in more detail, because there are some landforms like I can say glacial and fluvial, those formed by ice and those formed by water are more prone to physical weathering or are a result of physical weathering. In contrast to the karst topography or the underground features, which are mostly a result of chemical weathering, where you have dissolution of the calcium carbonate ions and formation of various topographies in the underground, like sinkholes, you have stalactite, stalagmites. So those would fall under the category of chemical weathering, as well as the fluvial and the glacial landforms will mainly fall under the category of physical weathering. So that's another important thing. Whenever there is the process of weathering taking place, another important thing to note is there is increase in surface area. That's something very obvious, because you have one rock mass with a certain surface area. When it breaks down, definitely you will have higher surface area as compared to the previous rock. So it leads to increase in surface area. And biochemical weathering, which is commonly seen in the first few meters of the soil. So when we see the depth of the rock or the soil, I can say biochemical weathering occurs usually in the first few meters of the soil, while physical weathering can occur in higher depths as well. So this is the basic idea behind what is weathering, the various functions and the characteristics of the process of weathering. Now, as I said, we can divide weathering into three criteria. One is biological process, physical process, and chemical process. Chemical process can be due to the attack of an acid, or it can be due to rusting, that is the process of oxidation, which we'll be discussing later. Under physical weathering, I can say the weathering can be due to high temperature, or it can be due to some mechanical action of say plants, animals, or ice. And finally, you have biological weathering, which includes action by bacteria or fungi. So let's first talk about the most simplest of these, that's the biotic or the biochemical weathering. Now there are four basic elements that affect the biochemical weathering. First is plants. plants usually have kind of two root systems. One is a taproot system and other is the fibrous root system. Fibrous root system is less deep and it kinds of spreads out in contrast to taproot system, where the roots go deeper into the soil. So wherever you have plants with taproot system, there is kind of deeper penetration of the root. As a result, there is disintegration, or I could say decomposition of the rocks to a greater depth. So that is one of the elements that affect weathering. So when I talk about plants, I can say this is one of the major reasons which helps in weathering or which promotes weathering, I could say. The other are the role of mycorrhizal fungi. So these fungi break down the existing particles into small particles. Similarly, there are action of bacteria which break down the compounds into smaller compounds. Now animals behave differently. You have termites, mostly common in humid or hot wet areas. Then you have some animals which are known for digging, some animals which are known for burrowing. Now all these animals like rabbits and all those animals which dig holes or burrows, what they do is they try to loosen the soil particle or rock particles. As a result, it causes disintegration of the rocks and promotes again the process of weathering. A common example which is known as farmer's friend is known as earthworm. Now earthworm, what it does is it loosens out the soil, and this loosened soil helps the farmers. As a result, it is also known as farmer's friend and also promotes the process of breaking down of the rocks. Then you have anthropogenic causes, those caused by human activities. You can have formation of gullies, formation of ravines, mining activities or related activities which are human induced would fall under the category of anthropogenic. So wherever there is a word anthropogenic, it deals with human beings. So human activities would definitely be involved in these kinds of activities. The next is physical weathering. Now physical weathering can be classified into 6 basic types. We would be discussing the first 2 ones and then we'll be moving further. So first is insolation and crystal growth. Insolation is due to, I could say, a change in the thermal gradient. So I have a kind of block of rock and this disintegrates. Now disintegration can be due to 2 reasons mainly. It can be due to temperature. If there is a very hot temperature and suddenly at night the area cools down, what would happen is there is the breaking down or the disintegration of the rock. The other is frost activities or effect of frost. So that would again affect the disintegration, and when the disintegration is in kind of blocks, it would be known as block disintegration. When the disintegration is in forms of granules, it will be known as granular disintegration. Both of them are mainly promoted by change in thermal gradient, specifically the change in the gradient during day and night. Exfoliation, it's also known as onion weathering. In this kind of weathering, there is a peeling that occurs which is similar to the, when you try to peel off the onion, this weathering is similar to peeling of the layers. The next is dirt cracking. Dirt cracking means it breaks down into smaller particles of, say, the size of dirt. So that's what is dirt cracking. And finally is boulder cleaving. Cleaving means again breaking down or disintegration. So the boulders or big rock masses breaks down into smaller rock masses. That is known as boulder cracking. And this usually occurs when you have the top area which is hot or which is prone to heat, but the lower area which is not under great stress. So when this happens, there is a kind of cleaving activity that occurs, and that is commonly known as boulder cleaving. And the next is crystal growth. Under crystal growth, we cover 4 types. The first is ice crystals. This is the most simplest one. So what happens is you have water present cavities within the cavities of the rock. When there is the cooling process that occur, the water within these rock particles kind of expands, and this expansion leads to cracking of the rocks, and this is known as ice crystal or crystal growth. Similarly, you have salt crystals which are found within the rock piece, and those crystals again promote the process of weathering. Now, important to note is either it's crystal growth or insolation, both of these are examples of physical weathering, because till now we are not talking about any chemical reaction that is taking place. The next is cavitation. When the water goes on into something with a huge force, it creates bubbles, and those bubbles leads to formation of cavities, and those cavities within the rock pieces leads to loosening of the rock and breaking it down. The next is colloid plucking. Colloid is a kind of, I could say, example could be clay, silica gel. So this is something that lies between a solution and a suspension. And when there is kind of plucking down of the clay particles due to alternate wetting and drying, it would be known as colloid plucking. So you have clay. When there is alternate wet and dry, what would happen? It would become wet very soon, and when it becomes dry, it would kind of put up with, you can see cracks or within that region, and that would be an example of colloid plucking. The next under physical weathering is loading and unloading. Loading means when a rock particle is having high load over it, so that would be an example of loading. But what would occur during unloading? During unloading, there would be a kind of crack, but it would not be able to hold that crack, and there would be removal of the load. So once the load is removed, we call that process as unloading. So there are three examples: rock sheeting, spalling and cambering. Under rock sheeting, it's kind of the most simplest of these three. There is sheets of rocks that are eroded, I could say not eroded, that are weathered away. So that is what is rock sheeting. It kinds of peels off in sheets or layers. When I talk about spalling, it's again flakes of rocks that are removed, but it is actually broken off at a much faster pace as compared to sheeting. And finally you have cambering. Under cambering, you have deep fractures in the vertical joints. So this is a rock and you have a vertical joint here. So here there would be a kind of very deep fracture, and that would lead to the process of cambering. The next is moisture swelling. So moisture swelling, when enhanced or under very cold condition, produces ice crystals, as we have seen previously. So moisture swelling is water molecules goes in and it swells out the rock particles, and because of the swelling it kinds of breaks down. So that is an example of moisture swelling. Next is slaking. Slaking is a season of alternate hot and dry area. So when there is wet and then there is again a period of which is dry. So when there is alternate wet and dry season, I could say it would lead to slaking. And finally you have the process of abrasion. So abrasion, I could say it's due to the frictional activity when two small particles kind of collide with one another. That's kind of abrasion, and that is another process of weathering. Now next is chemical weathering. Under chemical weathering, these are the major 8 types that we would be talking about. Now we'll start with the most simplest, dissolution. So if you put some common salt in water and you stir it, what happens? It dissolves off completely. Similarly is the process of dissolution. Under dissolution, we also call it as a process which is leaching. What happens is the element is completely dissolved in water. The best example is limestone, or I could say rock salt. The next is process of hydration. Process of hydration explains when water goes into, what happens is there is expansion, and this expansion leads to increase in the volume, and the water gets embedded into the lattice structure. So I could say any anhydride would convert into gypsum, would be a common example to understand hydration process. So you have anhydride, and it would form gypsum. So what is happening here is, as you can see, there is increase in volume and size. So that's the simple process of hydration. The next is oxidation. Oxidation, if I talk in layman's language, what happens? Once the process of oxidization is completed, the rate of weathering decreases. If I see iron and I can see a red coat on the iron, I can say this iron has rusted. So I could say rusting is an example of oxidation. But what is exactly oxidation? Oxidation means there is loss of electrons, and that loss of electrons increases the charge, and that is the process of oxidation. So if I talk about ferrous, if it reacts with oxygen and water molecule, it would form ferric oxide. Now this ferric oxide, if I try to understand the structure, I can say there are two ferrous molecules. Each of this have 3 electrons. Now this iron has the ability to lose the electrons. On the other hand, oxygen would be satisfied with 8 electrons, and it already have the 3 of the oxygen molecules have 6 electrons. Now what would happen is, this iron would give 2 electrons to this. This iron will give 2 electrons to this. So this is satisfied and this is fulfilled. Now the center molecule, center oxygen atom remains. So it will get 1 from this iron and another electron from this iron. So what is happening here basically is, iron is losing 3 electrons and each of the oxygen is gaining 2 electrons. So we can say Fe3 plus is formed, and that's the oxidation state for iron, and iron converts from ferrous to ferric, and this is a process of oxidation. So when I talk about oxidation, it's loss of electrons. The reverse of it is reduction, where there is gain of electrons. Now what is carbonation? Under process of carbonation, there is formation of carbonic acid. Now how carbonic acid is formed? If I say carbon dioxide reacts with water, so I have reaction of carbon dioxide with water, and this would lead to formation of carbonic acid. Now once this carbonic acid is formed, it would react with a rock. So I can say it reacts with calcium carbonate, and when it reacts with calcium carbonate, it would disintegrate the rock. So calcium ion would separate out, and there would be bicarbonate ion that would again be separated out. So that is a process of carbonation. It occurs due to the presence of carbonic acid, and this carbonic acid kinds of break down the rock and the mineral particle. The next is cation exchange. Under cation exchange, there is exchange of positive ions. So I can say within a lattice structure, you have hydrogen ions, and these hydrogen ions are now replaced by some other ions, say sodium ions or potassium ions. So what is happening here is, there is exchange of positively charged ions, and that this process is known as cation exchange. The next is chelation. What happens under chelation is, there are some chelating ligands that have high affinity for metals. So you have a metal here, and you have some agents that would bind with this metal, and they would show higher affinity towards this metal. As a result, usually these agents are organic in nature. As a result, this organic agent would take the metal from here, and there would be decomposition. Usually it is common. So I could say example could be humus breaks down to humic acid, is an example of chelation, is a perfect example of chelation. So what is happening here is, humus is breaking down into humic acid, and finally the rock is, the top layer of the soil is breaking down. Now this process helps the plants to mobilize metals from the soil, I could say. The next is hydrolysis. Hydrolysis is breaking down of hydrogen to hydrogen ion and hydroxide ion. Now this hydrogen ion and hydroxide ion again reacts. So you have the reaction with, say, any ion with a water molecule. I could say it would react to form a molecule, and there would be free hydroxide molecules, and this is an example of hydrolysis, very commonly seen in karst topographies. Hydration and dissolution we have already done. So these are some of the basic chemical weathering processes that we have discussed. The next is erosion. Now before we move on to erosion, let's go on to the differences between the chemical weathering and physical weathering. As we previously saw, physical weathering is due to some physical actions that are taking place, change in temperature, change in pressure, I could say, or there is heat or cold that is affecting the breaking down of the rocks, while under chemical weathering there is a kind of chemical reaction that is taking place. Chemical reaction takes place within the soil. So these are kind of more predominant, as I said, in karst topographies or underground topographies as compared to physical weathering, which is more common in say ice topography, that's the glacial topography, or river topography, that's the fluvial landforms. Now moving on to erosion, as I discussed previously, when weathered material is transported, this process is known as erosion, and erosion occurs in presence of certain agents. Now what are those agents? Those agents can be wind, water, rain, ice, snow. So these are some of the agents. So we will be talking about few of those. First is water. When I say water, what is happening? Water either combines with the existing rock particles and leads to the process of erosion. So there can be kind of sheet erosion, there can be gully erosion, and the various types of erosion that we have already covered under the section of soil erosion. So sheet erosion means the top layer gets removed. Gully erosion is a kind of deeper erosion. Now affected by ice, there can be activities of plucking, thawing that will be covering under glacial landforms. Wave also cuts out the platform and erodes away the rock material. Then you have the action of wind. Wind blows away the eroded rock particle with it. You have biological reasons, and finally you have the role of gravity. So when there is role of gravity, I could say there can be landslide, there can be slumping, So these are some of the examples or erosion that is caused due to gravity. So these are the major agents of erosion. Now if we talk about the basic differences between erosion and weathering, weathering is just disintegration and decomposition of rock. On the other hand, erosion is disintegration, decomposition as well as transportation of the disintegrated rocks. When we talk about weathering, we usually talk about the types of weathering, where we say it can be either biological, it can be either physical or chemical weathering. But when we talk about erosion, we focus on the agents which lead to the process of erosion or which accelerates the process of movement. So that can be water, ice, wave, wind, gravity or biological causes. So this was a kind of very introductory class to help you understand the process of weathering and erosion. This class would be the foundation stone for the further lectures that we would be talking about, where we would be talking about the various kinds of landforms. So the glacial landforms, arid landforms and the karst landforms will have all the ideas and all the terminologies that have been discussed here would be going in those further lectures. You can subscribe to Examrace channel for any further updates. Have a good day ahead.